Hello viewers, welcome to this session. We eat various fruits throughout the year according to their season. Every fruit has got its own characteristic taste and flavor. The taste in these fruits is due to some sweetness and some sourness in them. Tamarind is also very sour. This is vinegar, which is also very sour, regularly used in our kitchen. The sourness of all these substances is due to the presence of a particular type of organic substances called carboxylic acids. Aspirin, which is used as medicine, is also a carboxylic acid. So, we are going to devote our today's session to these carboxylic acids. We will discuss about their introduction. Then we will talk about the structure of carboxylic acids, classification of carboxylic acid. We will move on to the nomenclature, the common system as well as IUPAC system. Then we will discuss some methods for the preparation of carboxylic acids, and we will summarize our today's work. Carboxylic acids are organic compounds that contain carboxyl group. COOH group is called carboxyl group. Many carboxylic acids, they occur in nature. The carboxyl group was named so because it can be considered as a combination of carbonyl group and hydroxyl group. You see, this is carboxyl group. It contains one carbonyl group to which one hydroxyl is attached. You have already studied about the aldehydes and ketones which contain carbonyl group and alcohols which contain hydroxyl group. And this functional group, which is the combination of the two, shows entirely different set of properties. It is also written as CH3COOH together. COOH group is called carboxy group or carboxyl group, whereas these substances containing this group are called carboxylic acids. When this R is equal to HR alkyl group, then these acids are called aliphatic carboxylic acids. And when this R group is some aromatic system, some aryl group, then they are called as aromatic carboxylic acids. As far as the structure of this functional group is concerned, this carbon is sp2 hybridized and it is attached to this oxygen by double bond, that is one sigma bond and one pi bond, and then it is attached to another oxygen by a sigma bond. This oxygen is attached to hydrogen. When we look at their bond lengths, since this is CO double bond and this is CO single bond, obviously this is shorter and this is longer. These bond lengths are 121 picometer and 136 picometer. This carbon is sp2 hybridized, so expected angle is very near to 120, which is here 119 degrees. If we compare this bond length with alcohols, that is CO bond here and CO bond in alcohol, we find that here the CO bond is 136 picometer, the single bond, whereas this CO single bond in alcohols is 143 picometer, means this single CO bond length is also shorter than that in alcohols. One of the reason for that is this carbon is sp2 hybridized. So, the orbital that is used for overlap with the orbital of oxygen is shorter, has larger S character, which is about 33%. And in alcohols, this carbon is sp3 hybridized, where this is 25% S character. So, this orbital is slightly larger and hence formed a larger bond. Carboxylic acids are classified as mono, di or tricarboxylic acids depending upon the number of carboxyl group present in them. Means if it is one carboxylic group present in them, we call them as monocarboxylic acids. If there are two, then we call them as dicarboxylic acids, and so on. And they can also be classified as aliphatic or aromatic, as I mentioned before, that when this carboxyl group is attached to some aliphatic system, some carbon chain, they are called aliphatic acids, and when this carboxyl group is attached to some aromatic ring, they are called aromatic carboxylic acids. How to name them? These carboxylic acids have been known for a long time and as a result many of them have got their historical names that refer to their source rather than to their chemical structure. These names usually come from a Latin or a Greek word, because these were the languages used long back, that indicate their original source. Some of the common names for such acids have been listed, like formic acid. This is present in ant. Ant in Latin is known as formica. So from there the name formic acid has been derived. Similarly, acetic acid is present in vinegar, and vinegar is in Latin named as acetum. So from there this name acetic acid is derived. Similarly, these are the names propionic acid, butyric acid, caproic acid also based on their sources. When we want to name some other acid according to common system, then this carbon chain is considered and the carbons are named as alpha, beta, gamma starting from the carbon next to the carboxyl group. Means the carbon to which carboxyl is attached is called alpha carbon, next to it is beta, gamma and so on. And if there are any substituent present on these carbons, they are written by prefixing these letters alpha, beta, gamma, etc. Let us take the example. Suppose this is the acid. This is a 4 carbon acid, 1, 2, 3, 4. Overall there are 5 carbons, 4 carbon in the chain. So it can be considered as a derivative of butyric acid. Now this methyl group is attached at this carbon, which is alpha beta. So this compound is named as beta methyl butyric acid. Let's take another example. 1, 2, 3, 4, 5. This acid has got a 5 carbon chain. So this is valeric acid, and there is a chlorine present at alpha, beta, gamma position. So this is named as gamma chlorovaleric acid. Similarly, we can name other acids which do not have directly the common names as a substitution of some other common acids. These carboxylic acids can be named more systematically by IUPAC system. In IUPAC system, carboxylic acids are identified by a suffix oic acid, and monocarboxylic acids are named as alkanoic acids. Now remember here that while writing the names of compounds containing various other functional groups which you have studied, the name is one word, whereas in carboxylic acids the name consists of 2 words. There is a gap after this alkanoic and acid. Acid is written with a gap. The rules are: the longest chain of carbon atoms containing the carboxyl group is selected, and the name is derived from the corresponding alkane by replacing the suffix E with oic acid. So we take a longest chain, then according to that alkane it becomes alkanoic acid. E is replaced by oic acid. Number the carbon chain in such a way so that the carboxyl group is assigned position number 1, but this number is omitted while writing the name. Obviously we will require this when there is some substituent present on the chain, and all other usual rules of nomenclature are used. These are the names of some simple carboxylic acids. HCOOH, it's a 1 carbon acid, means derived from methane. Its IUPAC name is methanoic acid. CH3COOH, 2 carbon acid, means derived from ethane. This is named as ethanoic acid. Similarly, propanoic, butanoic, pentanoic, say it's a 6 carbon acid, it's called hexanoic acid, and so on. It is to be remembered that C2 position in this system corresponds to the alpha position in common names. In common names, alpha carbon is one to which carboxyl group is attached. In IUPAC system, the carbon of the carboxyl group is given number 1. So don't confuse while numbering in the common system or in IUPAC system. Now let us name some compounds according to IUPAC system. This is a compound. It is 1, 2, 3, 4 carbon chain containing acid. If this is carbon number 1, this is 2, this is 3. So there is a methyl group present at carbon number 3. So this is a 4 carbon acid, butanoic acid, and a methyl present at carbon number 3, it becomes 3 methyl butanoic acid. Let's take another example. Now this is 1, 2, 3, 4, 5. 5 carbon chain acid means it's a pentanoic acid, and it has got a hydroxyl group at 1, 2, 3, 4th position. So it is named as 4-hydroxy pentanoic acid. For practice, we can take another example. This is 1, 2, 3, 4, 5. Again a 5 carbon chain. So it's a pentanoic acid having 2 methyl groups at carbon number 2 and carbon number 4. So this is 2,4-dimethyl pentanoic acid. Then this acid has got 1 hydroxyl and 1 chloro. Now here the preference is given to carboxyl group. You have already studied these rules for giving the preference to the functional group. Carboxyl group gets the highest preference. So again we will number the chain from this side: 1, 2, 3, 4, 5. It's a 5 carbon acid, means pentanoic acid, having 1 chlorine at carbon number 3 and having 1 hydroxyl at carbon number 4. These substituents are written in alphabetical order. So it is 3-chloro 4-hydroxy pentanoic acid. Compounds containing 2 carboxyl groups are called dicarboxylic acids or simply diacids. Diacids are named using the suffix dioic acid without replacing E of the parent chain. Here the E in the parent alkane remains, and after E we add dioic acid. There are few examples here, such as this is a 2 carbon acid, commonly it is known as oxalic acid. This is ethane dioic acid. This is a 3 carbon acid, so it is named as propane dioic acid, and commonly it is known as malonic acid, and so on. If the carboxyl is bonded to a ring, then first that ring is named and then the word carboxylic acid is added to it. In this case, the carbon which is bearing the carboxyl group, that is given the number 1 on the ring. Now we don't give number 1 to carboxyl group. Now we give number 1 to the carbon of the ring to which carboxyl group is attached. Let us take this example. This is a 5 carbon substance, that is cyclopentane. Here is a carboxyl group present, a bromine and a chlorine also. So this carbon will be given the position number 1, and a bromine is also present at 1, and then we can number from this side 1, 2, 3, 4, or from this side 1, 2, 3, 4 and so on. But you remember that while we are numbering the carbon atoms in a ring, we go in that direction so that the other carbon bearing substituent gets the lowest possible number. So we will have to number this ring from this side. So now there are 1 bromo at carbon number 1, 1 chloro at carbon number 2. We write these substituents in alphabetical order: 1 bromo, 2 chloro, cyclopentane carboxylic acid. We have not given this number for carboxylic acid because it is understood that this was given number 1. But since bromine is also present at this carbon, we have prefixed bromo by position number 1. Then coming to aromatic acid. This is the simplest derivative of benzene, and it is also called as benzene carboxylic acid. But there is a one common name for it, benzoic acid, and this name has been accepted by IUPAC also. And other derivatives of this substance having some substituent at different positions are numbered accordingly, taking benzoic acid as the base name. For example, we have this methyl group at carbon number 2 of the ring. So we name this substance as 2-methyl benzoic acid. And in the common system, you know, these relative positions are named as ortho, meta or para. So this is orthomethyl benzoic acid. Some other examples. This is 1, 2, 3 compound with nitro group at 3 position. This is called 3-nitrobenzoic acid or meta-nitrobenzoic acid. Similarly, this is a 4-chlorobenzoic acid or para-chlorobenzoic acid. These are the compounds with 2 carboxylic groups. aromatic compounds. This is called as benzene 1,2-dicarboxylic acids, and a common name for this substance is phthalic acid. Whereas this is benzene 1,4-dicarboxylic acids and its common name is terephthalic acid. These are some unsaturated dicarboxylic acids, and these are two geometrical isomers for the same acid. This is a cis isomer, this is a trans isomer, and this is a 4-carbon acid, dicarboxylic acid with a double bond. So there are many features in it. So this is a 4-carbon means butane derivative. There is a double bond means it is butene. Double bond is present at carbon number 1, 2, 3. So between 2, 3, so that will be numbered as 2. So it is but-2-ene, and then positions 1, 4 for acid. So it is called but-2-ene 1,4-dioic acid. Now these two isomers will have the same name, only difference is this is cis isomer, this is trans isomer, so they are prefixed by these words also, cis and trans. This is cis but-2-ene 1,4-dioic acid, this is trans but-2-ene 1,4-dioic acid. This is commonly known as fumaric acid and this is commonly known as malic acid. If the carboxylic acid is such that aromatic ring is attached to some other position on the chain, then they are named as derivatives of the corresponding aliphatic acids. For example, if there is a 3-carbon chain like this, acid is on the aliphatic chain, benzene ring is attached here, so this acid is simply named as 2-phenyl propanoic acid. This is citric acid, which is a tricarboxylic acid and having one hydroxyl group also, a common constituent of all citrus fruits. Now let us move on to preparation of carboxylic acids. How they are prepared. Carboxylic acids can be prepared by the oxidation of many functional groups, alcohols, aldehydes, and also ketones. But when oxidation of ketones is carried out, the chain breaks on the either side of the carbonyl group. We end up with mixture of carboxylic acids. So that is not considered as a very good method for the preparation of acids. When we carry out the oxidation of alcohols, they are obviously in the first step oxidized to aldehydes, which get further oxidized to carboxylic acids. So that is why we consider the method for the preparation that oxidation from primary alcohols. These primary alcohols can be easily oxidized by the most common oxidizing agents like potassium permanganate or potassium dichromate. Potassium permanganate can be used in acidic medium as well as in alkaline medium. Here is an example. Say this is 3-methyl butane 1-ol. Now this is a carbon containing OH group, primary alcohol, and this carbon gets oxidized to COOH group. So this becomes 3-methyl butanoic acid. This is one of the very common method which we use for preparation of carboxylic acids. In this method we will get the carboxylic acid containing as many carbons as were present in starting alcohol. The next method is we can obtain carboxylic acids by ozonolysis of alkynes. Alkynes are the compounds with carbon-carbon triple bond, and with the help of ozone followed by hydrolysis, these two carbons which were attached by triple bond are converted into carboxylic acids. So we will end up with mixture of two carboxylic acids, one from this part of the molecule and another from this part of the molecule. But suppose if it is a terminal alkyne, then this carbon which has got no alkyl group will be oxidized to carbon dioxide and another will give us the corresponding carboxylic acid. Next we can carry out the oxidation of an alkyl group that is attached to some aromatic system such as alkyl benzene. Here also the most common oxidizing agents are potassium permanganate and potassium dichromate. And second thing in this method is that whatsoever is the length of the carbon chain attached to benzene, it is ultimately oxidized to one carbon group, that is carboxyl group. Such as if we start with toluene, this methyl group is oxidized into carboxyl group. We get benzoic acid. Even if we start with ethyl benzene, this ethyl group is also ultimately oxidized to carboxyl group. Means all other remaining portion of the chain, they get oxidized into carbon dioxide etc. and we get benzoic acid as a product. Another method which is very important and most commonly used for the preparation of carboxylic acid is carbonation of Grignard reagents. You have studied earlier that Grignard reagents, which are obtained by the treatment of alkyl halides with magnesium metal, they are the substances RMgX, alkyl magnesium halides. These are organometallic substances, and they add on to compounds containing C double bond O, that is carbonyl group. You have studied their reaction with aldehydes, ketones. Similarly, they add on to carbon dioxide, and when a molecule of Grignard reagent adds on to one molecule of carbon dioxide, we get RCOOMgX, and this gets hydrolyzed to RCOOH. So we get carboxylic acid. Now this carboxylic acid has got one carbon more than the starting alkyl halide. This carbon has come from carbon dioxide. If we start with an aromatic substance, that is an aryl halide, we will get an aromatic carboxylic acid. Here is an example. Say if we start with 1-bromopropane, it is treated with magnesium, we get propyl magnesium bromide. It is added on to carbon dioxide followed by hydrolysis. We get a 4-carbon acid called butanoic acid. This is another example. If there are many substituents and highly sterically hindered compound, like this is tertiary pentyl chloride, even this reacts with magnesium to give corresponding Grignard reagent, which adds on to carbon dioxide followed by hydrolysis, gives this acid, which is 2,2-dimethyl butanoic acid. So this method, carbonation of Grignard reagent or addition of carbon dioxide with Grignard reagent, gives us the carboxylic acids with one carbon more than the starting alkyl halide. Another common method for the preparation of carboxylic acids is from cyanides. Cyanides can be hydrolyzed in acidic medium as well as in alkaline medium to corresponding carboxylic acids. This is the final hydrolysis product, although the hydrolysis proceeds through amides in between. So cyanides are ultimately hydrolyzed to carboxylic acid. If it is acidic medium, we get directly acid. If we are doing it in alkaline medium, then initially we will get anion of the carboxylic acid, which on treatment with some acid is ultimately converted into carboxylic acid. So these method, the Grignard reagent as well as this method using cyanide, if we want to start it from corresponding alkyl halides, again can be used for increasing the chain length by some carbon atom. This method, while doing conversions, we call it as stepping up the series. That is a chain reaction or a sequence of reactions where number of carbon is increased, we call it as a stepping up the series. And both these methods, using through nitriles or by the carbonation of Grignard reagents, we can increase the chain length. Here it is summarized. This is suppose any alcohol, RCH2OH, primary alcohol. If it is directly oxidized, we will get the carboxylic acid containing same number of carbon atoms. If this alcohol is converted into alkyl halide, say here example with PbR3 is given, we are getting alkyl bromide, but we can prepare any halide using different reagents that you have already studied in preparation of alkyl halides. This alkyl halide has got the same carbon atoms as in starting alcohol. Then this alkyl halide, if it is treated with magnesium, we will get the Grignard reagent, and when this Grignard reagent is added to carbon dioxide, we will get carboxylic acid with one more carbon than the starting alcohol. Similarly, if this alkyl halide is treated with sodium cyanide or cyanide ions, we will get corresponding cyanide, and when this cyanide is hydrolyzed, again we will get the carboxylic acid which has got one carbon more than the starting alcohol. And these reactions are very useful while carrying out the conversions in the organic chemistry. So today we have discussed about the carboxylic acids. What are these? What is the structure of carboxyl group? How they are classified? how they are named, and what are their general methods of preparation. In our next session on carboxylic acids, we will discuss their properties. And one of the most important property regarding this carboxylic acid is their acid strength. Amongst different functional groups in organic chemistry, these are the most acidic functional group. But these compounds are much less acidic than the mineral acids like hydrochloric acid or sulfuric acid, etc. So we will compare the acidic character of these carboxylic acids with other functional groups like alcohol or phenols, and then we will discuss that how their acidic strength varies when some substituents are changed in carboxylic acids themselves. Thank you.